Hi, Math 2. We are beginning the last section of this chapter, so it's section 7.5. If you want to open your book to page 454, we can go ahead and get started. There's a couple of new terminologies. If you look at the gray box on that page, you're going to be looking here at what is called an apothem. The apothem comes from the center and it drops straight down at a 90-degree angle. What you have is a circumscribed circle about this shape, and we're only going to be dealing with regular polygons today. Regular means that all sides are the same length, all angles are the same. So you're going to inscribe that inside of a circle. You have the center of the circle, and then there you have your radius, which goes into the vertex of the polygon and touches the circle. So pretty much the new word right here that we need to know is your apothem when you go through. So we're going to go through an example, like the one at the bottom of your page. It is dealing with an octagon, and it wants to know the numbered angles. All right, so what you can do with this is, you know that right through here you have 360 degrees, so you're going to go and you're going to take 360 and divide it 8 ways since it's an octagon. So let's see what we get. We get 45. So the measure of each of these angles right here around the center are going to be 45 degrees. So the measure of angle 1 is 45. And then when you drop down this apothem, since this is going to be, each of these is a radii, which means they're the same length. We have an isosceles triangle right here. So this apothem will cut this angle in half. So the measure of angle 1, we said, was 45. So the measure of angle 2 would be half of 45. Okay, so we get 22.5. And then to find the measure of angle 3, there's a couple of different ways. If you remember a while back, we found this whole angle by taking n minus 2 times 180. That got you the sum of an octagon. And then you could divide it 8 ways to get each of these individual angles. And then you can cut it in half because this comes down. Or if you know that this angle right here is 22.5, you have a nice little right triangle right here, and you can just take 90 minus 22.5 to get that angle 3. Okay, so that looks like it's 67.5. Okay, but you can do that with any shape, any angle. You just take however many little angles are on the circle, divide it evenly into 360 because you have a complete circle. Angle 2 will be half of angle 1 because your apothem, and then you have this nice little right triangle right here. All right, if you want to go ahead and flip over to the next page, we are going to talk about how to find the area of a regular polygon. All right, we have this little formula right here. And again, regular means that all sides and all angles are the same. And you can even do this on a regular triangle, a regular quadrilateral, anything that is a regular shape. So the area is 1/2 the apothem times the perimeter. Okay, so it tells you right here, 1/2 the apothem times the perimeter. And you remember the perimeter is the distance all around a shape. All right, so let's go through and turn your page. And if you take a look at this first problem up here, it wants to know the area of a regular pentagon that has an apothem of 8 and the sides are 11.6. All right, so you have a regular. Okay, and it gives you your apothem to be 8. So you're going to put that in place of your apothem. And in order to get your perimeter, you take the side length times however many sides there are. So they tell you the side is 11.6 and there are 5 of them. So you'll take 11.6 times 5 and you get 58. All right, then just go ahead and put that into your calculator. And you should get 232 square centimeters. Okay, remember area is always labeled as squared. Okay, so let's go down to your practice down here. And again, it just wants to know the area and to the nearest square unit. All right, so we have, excuse me, a 7gon. So you're going to take 1/2, 29. You need to find the side length is 28. So take 28 times 7 to get your perimeter. All right, then multiply that times your apothem, which is 29.1. And then you will take half of that. So you should get 2,851.8, which rounds to 2,852 square feet. All right. All right, what we're going to do is we are going to start using special triangles to find the area to do this. So I am going to switch over to a worksheet I have right here to explain this. I don't know why they keep writing 12 here. It's 1/2 your apothem times your perimeter. All right, when you have a regular triangle, if you can just imagine that you have a circle, drawn around here like this. Okay, you're going to drop down your apothem from your center at a 90-degree angle. Now, since this is a regular triangle, that means all the angles are the same. Triangles add to 180, so each of these angles are going to be 60. And then when you drop this radius down like this to hit that circle, it's going to cut that 60 in half, so this really becomes 30, and that's 60, which is why we learned last section your 30, 60, 90 rules. All right, so here we go. In order to find the area of this triangle, all right, we need the height of this apothem right here, and we're going to put that there, and then we need the perimeter. Well, they're already telling us that this side length is 9, so if the side length is 9, you take 9 times 3 to get your perimeter, which is 18. All right, so this apothem comes down, cuts this in half, so this is 4.5. All right, because it is regular, that means the whole length of each of the sides are 9, so you get 4.5. Remember, that is your long leg. It's across from the 60 degrees. So your apothem is actually the short leg. So what we need to do is to go from the long to the short, we divide by the square root of 3. All right, so go ahead to your calculator and take 4.5 divided by the square root of 3. All right, and we are going to round that. It tells us here we're going to round to the nearest tenth. So let's go ahead and round that to the nearest tenth, which is 2.6. So our apothem right here is 2.6. All right, now you can go ahead and go to your calculator and multiply that out. What I would probably do, I had did this in my calculator, left the decimal out. I don't know if it'll make much of a change, but I'm just going to leave that in there as that. There's your apothem, and then I'm just going to take half of 18, which is 9. So I'm going to go ahead and just multiply this times 9. And we get 23.4 for our area. Okay, and then that will be square feet. All right, let's see. All right, let's go down here. Let's do this triangle. We have area, or the side length is 16, so your perimeter is going to be 16 times 3. All right, so we get a perimeter of 48. We're going to go ahead and pretend again that we have a circle drawn through here, so this would be the radius that would touch the circle. Drop down your apothem. This will always be a 60. So this is going to be 8. All right, which means this is 8 divided by your square root of 3. Okay, will be your apothem. Okay, so let's go and do area is 1/2. And again, you can go to your calculator and do the 8 square root of 3. 8 divided by the square root of 3, and then take that times 48, or you can take half of 48 right now and just put 24. All right, so go to our calculator. We're going to take 8 divided by the square root of 3, and then we're going to multiply it by 24, and we get 110.9. And that would be centimeters squared. All right, and there's your area. All right, what we have on this one is we have a hexagon. All right, on a hexagon, what happens is all hexagons add up to 720 degrees. So if we take 720 and divide it by 6, that leaves us with each of these angles being 120. So when I go and I do the same thing, I'm going to drop this down again. Remember, we are enclosed in a circle. All right, so when I drop this down, that's really the radius. It's going to cut that 120 in half. So this is going to be the 60, and this is going to be the 30, all right? Just flip-flopped around from my triangle. All right, so if the side length is 16, we have 6 sides this time, so take 16 times 6, so our perimeter is going to be 96. It does the same thing. It's going to cut it in half, so 8 will be here, but this time the short leg is 8, which means the long leg is now your apothem. So we're going to take 8 square root of 3. So go to our formula. We're going to take 1/2 times your apothem times your perimeter. All right, so go ahead and multiply that out. And looks like we get 665.1 for the area of that hexagon. All right, and you can do the same thing here. You'll just get a decimal. When you drop it down, your short leg will become half of 3, which is 1.5. All right, so you know how to do your regular triangle. We know how to do a regular hexagon. Let's go and talk about a square. Okay, so again, if you can imagine, you have a square that's going to be enclosed in this circle. This is going to be your radius. All right, we're going to drop down your apothem. All right, which gives you your 90 degrees. Now, again, this cuts this in half. Well, squares have a 90-degree angle, so this is going to become a 45, 45, 90, which we're going to have to follow those rules. Okay, 12 was your radius here to begin with. So if that is 12, to go backward to a side length, because we still need our perimeter and the apothem, you divide by the square root of 2 to go backward. So if you write it all out, we're going to get 6 squared root of 2 is what this comes to be. So 6 squared root of 2, 6 squared root of 2. There we go. So to get the side length right here, 6 squared root of 2 plus 6 squared root of 2 is 12 squared root of 2. If you add those together, you just add the 6 plus the 6. That is one side, which means this side is also that, and that's also that. So we're just going to take that times 4 to get our perimeter. So our perimeter is 48 square root of 2. Our apothem is 6 square root of 2. All right, you can go to your calculator and do it, however you want to do that, and then you're going to take 1/2 times both of these. Remember, when you take the square root of 2 times the square root of 2, you really just get 2. So you're taking 48 times 6 times 2, and then taking half of that. Well, half of 2 is just 1, so it's 48 times 6, which is 288. And that would be, I think, inches squared. All right, so let's see if we can do, well, we kind of already done most of those. All right, so that's all you're going to be doing today. I don't know what our homework is. I'll have to look when I get to school. And I'll post that on Google Classroom. But your square, you're going to have your 45, 45, 90s. On your triangle, you're going to have your 30, 60, 90, where 30 will be down here. 60 is here. And then on your regular hexagon, you will have 60 down here and 30 up here. You just follow your 30, 60, 90 rules. The only thing you need to find is your apothem and your perimeter. Plug it into your formula for area and just make sure you label it as units squared.